Okay, this is lesson 4.3, solving systems of inequalities. In the inequalities unit of Math 1 in Khan Academy, we are covering skills 3, 7, and 8. So in chapter 3, we covered systems of linear equations, and now we're going to do the same thing but with inequalities. So we have two variables, x and y. It looks something like that. And instead of equal signs, we have greater than or less than symbols. Excuse me. But over here in the margin, this is old. You can just say lesson 4.2. We just talked about graphing inequalities in the last lesson. In chapter 3, when we had systems of equations, we graphed two lines. So we may have had a blue line for one equation and let's say a red line for another equation. And the solution to that system of equations, when we solve it graphically, would be where those two lines cross, because that point is on both lines. The only thing that's going to change now is the blue line isn't going to be an equation, it's going to be an inequality. So it could still be a solid blue line, and maybe we shade below if it's like less than or equal to. But the red line, maybe it could be solid also, maybe it's dashed. And we'll either shade above or below because it's also going to represent an inequality, not an equation. So let's say I shade above. Let's say it's strictly greater than. Then our solution is going to be anything on this blue line because the blue line was solid up to here. But it's not going to include anything on the red line because the red line was dashed. Those aren't considered solutions to the red equation. But it's also going to include everything that's shaded both red and blue. So this region of the graph here, anything in there would be a solution. We'll get more into the graphing part in a moment. But for this first example, I might ask you, or you might see something on Khan that says, hey, is this point a solution to the given system? So a solution to this system of equations right here. And if it's a solution, then it needs to satisfy both inequalities or all of the inequalities in that system. So we'll plug those values in. We'll plug in 3 for x and -5 for y. And we should get true statements for the first inequality and for the second inequality. I'd like you to try this on your own because we've done this in previous lessons, and then come back and check your work. You can show your work right over here and pause the video, and we'll be right back. Okay, so if we plug in 3 for x and -5 for y, into the first inequality right here, we end up getting 3 minus -5, which is 8. And this is a true statement because 8 is greater than 7. So the point is a solution to the first inequality. We still have to check the second inequality. So we plug in 3 for x and -5 for y again. And if we multiply 2 times 3 is 6, and then we have to add -5 and we'll get 1. This is also true because 1 is less than 8. Since this point satisfies both inequalities that make up this system, we can say that yes, it is a solution to the system of inequalities. Let's try the same thing, but with a new point. Is 5, -2 a solution to this same system? You can do your work over here, pause the video, and then come back and see if we get the same answer. All right, there we go. So we don't get a true statement this time. If we plug in 5 for x and -2 for y into the first inequality, we end up with the statement 7 is greater than 7, and that's false. We don't even have to check the second inequality because for 5, -2 to be a solution to the system, it has to satisfy both. If it doesn't satisfy the first one, then we're done. We can say no, it is not a solution to the system of inequalities. Okay. So I talked a little bit about graphing, but let's go ahead and dive right into graphing now. If we're going to solve this system of equations by graphing, let's graph the first one. I'm going to get this in slope-intercept form. You don't have to. You could graph it using intercepts. I just like using y equals mx plus b form. So I'd be left with 2y on the left side of this inequality. I'll have negative 3x plus 6 on the right. And if I divide both sides by 2, I have to divide each term by 2 in this case. 3 is not divisible by 2. Rather than figure out a decimal or anything, we write it as a fraction. That'll help us with our slope later anyways. And then 6 divided by 2 is 3. So we can graph this. This is our first equation, just written in slope-intercept form. I keep saying equation. This is not an equation. This is an inequality. Go up to 3. That's our y-intercept. And then our slope is negative 3 over 2. So I'm going to go down 3 and over 2. Put my point, and I can go down 3 and over 2 again. Put another point. And draw our line. It is a solid line because I have this equal to line underneath the less than symbol. And then we can graph our second line. Oops. Before we do that, this is an inequality. We need to shade, and because it says less than or equal to, we're going to shade below the blue line. So all these points that I'm highlighting are solutions to the first inequality in our system. But there's two inequalities in the system. So now let's go ahead and tackle this second inequality. There's no y in this inequality, so we're not going to get it in slope-intercept form or y equals mx plus b form. It's just x and a number. The boundary line is x equals 2, so we'll go to 2, and x equals 2 is a vertical line. It's a dashed line because it doesn't say or equal to. And we can use a test point if we want, like the origin. The x-coordinate of the origin is 0. So we need to ask ourselves, is 0 really less than 2? Yes, it is. So we're going to shade to the side of the red line that includes the origin. And you might have been able to figure that one out on your own, even though it's a vertical line and you can't really shade above or below it. When we have less than, we're going to shade to the left of a vertical line. So we shade all that in. And the overlap is going to be everything on this blue line that's touching the overlap. Not the stuff that's on the red line because the red line is dashed, but everything in here, everything in this region will be a solution because it's shaded by the red inequality and the blue inequality. Okay. I'd like you to try number 3 on your own. Do the same thing we did in example 2, except that in this case there are 3 inequalities. So our solution is just going to be the area that's shaded by all 3 inequalities. Once you've done that, come back and check your work. Okay, there's our solution. Switch over to my pointer, there we go. So our first inequality I chose to graph in blue. Y is greater than or equal to -1. So our boundary line is at y equals -1, and it's a solid line because we have the greater than or equal to. And because it's greater than or equal to, we're shading above the blue line. And you can kind of see the blue highlighter in here. The second inequality is x is greater than -2. So our boundary line for that inequality is at x equals -2, but it's dashed because it's strictly greater than, not greater than or equal to. Finally, because x is greater than, we're going to be shading to the right. You can see the red highlighter, some of the overlap here, all this stuff is highlighted in red. And then the third inequality is not in slope-intercept form. I chose to get it in slope-intercept form, but again, you could have used graphing by intercepts here and here. It's up to you. Either way, you need to graph the boundary line, which would be a solid line because it has the or equal to line. And because when it's in slope-intercept form, we have less than or equal to, we're going to shade below, and that's all the green highlighter. And so our solution to this whole system of inequalities is only the area that's shaded by all three inequalities. So you can see I drew the line here, the yellowish line there, because the green line was solid and the blue line was solid. So all the points there are solutions to our system. Everything in the shaded region is also solutions to our system, but nothing on the red dotted line, again, because it's a dashed line or dotted line. Okay, let's do example 4 together. Is 0, -1 a solution to the following system? And they don't give us the system explicitly, but they do give us the graph. So looking at this graph, we can plot 0, -1, and that's right here. That point is not in the shaded region, or not even touching the shaded region. So no, it is not a solution. Let's try 2, -2. So if we go to 2, -2, that point is in the shaded region, so it is definitely a solution. I'd like you to try the last two on your own. Come back and check your work. Okay. So 2, -5 is down here. It's touching the shaded region, but it's on a boundary line. And because that boundary line is a dashed line, it is not a solution. That kind of gives away the answer for the last one, because 3, 0 is right here. It is touching the shaded region, and it is a point on a solid line. So yes, it is a solution. All right, here's your last example. Again, try this one on your own. Graph the two lines, shade to either above or below on each of them, and then see where they overlap. Okay, so for example 5, this is kind of a special case because there is no overlap. So if you ever have something like this, then there's no solution. I would like to point out that you can still have parallel lines when you graph inequalities and still have a solution, because if I switch this to less than and shaded below the blue line, then all the stuff in red would also be shaded in blue and you'd have a solution. But in this case, we shaded above the blue line and below the red line. There's nothing that is shaded in both blue and red, so there's no solution. That's it for lesson 4.3. As always, ask a question at the end of the video or make up a question, and I will see you all in class.